All right, guys, here's another CPCTC proof, and we know that because if you look at our proof statement here on number 4, you can see we're not proving the two triangles are congruent. We're proving that the angles are congruent from our top triangle to our bottom triangle. All right, so I'm going to tell you that there are 7 in here, but we wouldn't necessarily have to know that. You could just go ahead and write up your statements and reasons and go until you get the triangles are congruent, and then prove that the corresponding parts of the congruent triangles are congruent, or CPCTC. But I'm going to pause right now and just put in my givens and my proof statements, and then I'll be back in a second. All right, guys, I got my givens and my proof statement in here. Now let's see what they told us. All right, the first one, HJ is parallel to LK. HJ is the top one. We're going to say it is parallel using my little arrows to LK, as well as the second statement, JK is parallel to HL. All right, so JK is parallel to HL. I'm going to put 2 arrows on this one. Okay, so what does that do for us? Let's start with the first one. The first given says HJ is parallel to LK. That's our top and our bottom lines. Now, whenever you see parallel, I like to think of those lines extended and then maybe a transversal that goes through that. In this case, these ones. Okay, and what that's going to do for us then is, if you look compared to our transversal and our green line, is I'm seeing that there's an angle that touches both of those, and that's going to be this angle and this angle. And those are going to be alternate interior angles. Okay, so let me erase those lines and show you. Again, that's going to be this one and this one. All right, and let me switch back to my red. So that's going to be angle on the top. It's going to be HJL. Oops, angle HJL. Angle HJL is going to be congruent to angle. Now I have to go the other way. I got to be a little bit careful. It's going to be KLJ. KLJ. All right, and that is true because remember, if those are parallel and we have a transversal, now on the inside, but opposite sides of the transversal, that is alternate interior angle. So you can do AIA theorem if you want. Okay, same thing for number 4, but we're going to use, so number 1 showed us how to do number 3. Number 2 is going to show us how to do number 4, and it's almost the exact same using the opposite parallel lines, which in our case is these. All right, and then here's my transversal that goes through. Okay, and the ones that touch both on this one are here and here. So if I erase those, oops, too far, then it shows me that these, so those are alternate interior angles for the same exact reason. So that's angle, let me do the top one first, angle, let's go HLJ. HLJ is congruent to angle, let's see, that'd be KJL. KJL, and that's by the alternate interior angle theorem again. Okay, number 5 then, let's see, what else do I need in this one? I have 2 angles in the top and the bottom. Oh, and this, of course, is going to be reflexive because it's the same line butted up against each triangle. So that's LJ. LJ is congruent to itself, LJ, by the reflexive property. Okay. All right, so I think we have enough here. We have, let me put the tick marks on to show that. We have angle, side, angle. So we can say that triangle, remember that trick that we learned from before, if they give you 2 angles that are the same, just use those, but instead of the angle, use their triangle symbol now to say triangle LJH, or sorry, LHJ, in the order that they give us, right? LHJ is congruent to triangle JKL. So it's congruent to triangle JKL. And we said that was angle, side, angle. All right, so then we have our proof statement down here because we don't want to prove that the triangles are congruent, but after that, we want to prove that those 2 angles are that it told us. So because those 2 angles are congruent, is going to be the reason CPCTC, or corresponding parts of congruent triangles, are congruent.